Good morning, everyone. Welcome to the final and the concluding lecture of Chapter 5 Separation of Substances. In the previous lectures, we have studied how we can separate solids from a mixture of solid and solid from a mixture of solid and liquid. Today we are going to study about the techniques by which we can separate soluble solids from a mixture of solid and liquid. How we can get both the solid substance and the liquid. It can be done by applying the techniques of evaporation and condensation. In addition to this, we will also study how immiscible liquids can also be separated by using a separating funnel. Separation of soluble solids from a mixture of solid and liquid can be done by applying the technique of evaporation. You must have observed that when we spread wet clothes on a rope or a wire, they dry up after some time. Where does the water in the clothes go? The water present in the wet clothes evaporates when it receives the heat from the sun to form water vapors. This process of changing of a liquid like water into its vapors is known as evaporation. In nature, evaporation can take place at any temperature. You must have observed that the clothes they dry out in summers as well as in winters. In summers, the temperature outside is so hot, whereas in winters, the temperature is cold. Still, the clothes dry out. This means that evaporation can take place at any temperature. However, the rate of evaporation increases with increase in temperature. Similar is the wind speed. Wind speed also increases the rate of temperature. Third factor which affects the rate of evaporation is the surface area. More is the surface area, greater is the speed of evaporation. You can very easily observe this by doing a simple activity. Take some water in a glass and some water in a plate and keep it outside. You will observe that the water in the plate dries up very quickly in comparison to water in the glass. Fourth factor is the humidity. Humidity is the percentage of water vapors present in the air. More is the humidity, lower will be the rate of evaporation. The process of evaporation is used to obtain salt on large scale from seawater. Seawater is first of all trapped in shallow ponds called the lagoons, and it is allowed to stand there. The heat of the sun gradually evaporates the water completely in the shallow pits, leaving behind the solid salt. This mixture of salt is then further purified to obtain the common salt. Now there is an activity for you. Suppose I dissolve some common salt in water and ask you to separate common salt dissolved in water. How will you do that? You can do it very easily by applying the process of evaporation. You just take the salt water and keep it on the burner. When you heat it, then what happens? The water slowly and slowly evaporates to form steam. When all water that is present in the solution of common salt gets evaporated, common salt is left behind, and this is how we obtain it. Now let us study how a liquid can be separated from a mixture of soluble solid and liquid. It can be done by the process of condensation. You have studied already in your junior classes what is condensation. The process of changing back of vapors back into its liquid state on cooling is known as condensation. For better understanding, let us perform this activity. The activity is to separate water from salt solution. In previous slide, we studied how to separate salt from the salt solution. Now let us study how to separate water from the salt solution. This activity, dissolve about 20 grams of common salt in water to obtain the salt solution. Now pour this salt solution in a kettle and put it on the burner. When you place it on the burner, heat from the burner changes the water into water vapors, and the steam it starts coming out from the spout of the kettle. Now take a frying pan with some ice cubes in it. Hold the frying pan in the slanting position just above the spout of the kettle. You will observe that when the steam comes in contact with the frying pan containing the ice cube, it cools and condenses to form droplets of water. These water droplets trickle down on the underside of the frying pan and start falling down. You can collect these water droplets in another beaker. By this activity, we can conclude that water is separated from the salt solution through the process of evaporation and condensation. You can also perform this activity on your own under the guidance of your parents at your home also. Children, in the previous chapter, you must have studied about miscible and immiscible liquids. Miscible liquids are the liquids which mix with each other. For example, if I add water in alcohol, then they mix with each other and you cannot tell them separately. However, if I add some oil in water, these two liquids they are immiscible. Oil, being lighter in density, floats over the surface of the water and you can see the two separate layers. Now, let us study how the immiscible liquids can be separated from a mixture. When two liquids are immiscible, they can be very easily separated using a separating funnel. Remember the separating funnel? We did this in the lab activity video. In this activity, we pour the mixture of two immiscible liquids, say kerosene oil and water, in a separating funnel. The mixture is allowed to stand for some time. Kerosene oil, being lighter, forms a layer above water. Now we open the stopcock and the water is drained off in a separate container. Kerosene oil is left behind in the funnel and then can be collected in the second beaker.
Madam, how will you separate the components of a mixture of iron, sand and common salt?
A mixture of iron, sand and common salt can be separated using different methods based on their unique properties. Iron fillings get attracted towards the magnet, and salt can be dissolved in water. Sand particles can be easily separated from a salt solution using a filter paper. Let's do an experiment to separate a mixture of iron, sand, and common salt. The materials required are a bar magnet, sand, iron fillings, water, common salt, a funnel, a conical flask, a beaker, a wire gauze, a filter paper, a tripod stand, a china dish, and a Bunsen burner. Procedure: take a beaker and mix some sand, salt, and iron fillings in it. Before preparing the mixture, weigh each of the three solids separately and record the weights for further observation. Hover a bar magnet across the surface of the mixture to separate iron from the mixture. The iron fillings get attracted to the magnet, while sand and salt are left behind. Now add about 100 milliliter of water into the mixture. Stir the mixture but thoroughly. Filter the mixture into a conical flask using a filter paper. Sand particles, being insoluble and bigger in size, remain on the filter paper. Now transfer the liquid into the china dish and place it on the tripod stand. Light the burner under the stand. Heat the solution until the water evaporates completely. Allow the residue salt to cool down for some time. Collect the salt from the china dish.
Our next topic is solubility. Before studying solubility, let us first of all recapitulate what we studied in the previous chapter. Do you remember? Solute, solvent, and solution. The substance which is dissolved in a solvent to produce a solution is known as a solute. It is always present in the small quantities, and the substance in which the solute is dissolved to produce a solution is known as a solvent. Solute and solvent, they together make the solution. For example, when we dissolve salt in water, we get salt water, which is also known as brine. In salt water, salt is the solute and water is the solvent, and they together form the solution or the salt water. Now, water, it is known as a universal solvent because it can dissolve many substances in it. But of course, there is a limit up to which any substance can dissolve in water. For this, you can perform a very simple activity at home. Take a glass filled half with water and add a spoonful of salt in it. Stir it. You will see that the salt very quickly dissolves in the water. Now add 1 more teaspoon of salt in it and stir. After adding a number of spoonfuls of salt, we observe that some salt is left undissolved at the bottom of the glass. This means that no more salt can be dissolved in this much amount of water. Such a solution is known as a saturated solution. So, a solution in which no more solute, no more substance can be dissolved at a particular temperature is known as a saturated solution. Different substances dissolve to different extents in water at a given temperature. For example, sugar dissolves in water more than common salt. The extent to which a substance gets dissolved in a liquid is known as its solubility. Solubility of solid solute generally increases with rise in temperature. Let us study how in the next slide. Now let us study the effect of temperature on the solubility of solid substances. For this, let us take an example of sugar. You can understand this very easily by performing this simple activity at home. First of all, we will prepare a saturated solution of sugar. For this, take some water in a pan. Keep on adding small quantities of sugar in it and stir. You will find that after adding a number of spoonfuls of sugar, some sugar is left undissolved at the bottom of the pan. At this stage, we call it the saturated sugar solution. Now, keep the pan on the burner and start heating. On heating the sugar solution, the undissolved sugar at the bottom of the pan also gets dissolved. This shows that at higher temperature, more sugar gets dissolved. That means its solubility increases. Now take the pan off the burner and keep it aside for cooling. When you cool this super saturated hot solution, the sugar settles at the bottom of the pan again. This shows that at lower temperature, less sugar dissolved in water. By this activity, we can conclude that heating a saturated solution increases the solubility, and when the saturated solution of a substance is cooled to a lower temperature, solubility of the substance decreases, and even some of the dissolved substance separates out in the form of crystals.
Today, in this experiment, we are going to demonstrate how temperature affects the solubility of a gas. Let's start by boiling some water in a beaker. In a second beaker, add ice and water. Now pour a carbonated drink into a test tube. Place the test tube in the hot water. Notice the bubbles of carbon dioxide gas forming. Now place the test tube in the cold water. Notice how the bubbles slowed down? This is because gases are more soluble at a cold temperature. When a gas's kinetic energy increases, it becomes less soluble in a liquid solvent. The gas exerts enough pressure to overcome the atmospheric pressure keeping it in the liquid. The more kinetic energy a gas has, the harder it is to dissolve in a liquid solvent. This is the opposite of how it works with a solid. Look in the description for a link to a video about solids. I hope that helped. Thanks for watching.